Chapter 8.2, Operations with Matrices. We're going to determine whether two matrices are equal. We're going to add and subtract matrices and multiply matrices by scalars, multiply two matrices, and use matrix operations to model and solve real-life problems. And representation of matrices. A matrix can be denoted by an uppercase letter, such as A, B, or C, or a matrix can be denoted by a representative element enclosed in brackets, such as here. And then a matrix can be denoted by a rectangular array of numbers, and we see that here. We see that two matrices A equals Aij and B equals B sub ij are equal when they have the same dimension, m by n. And you see these other restrictions here. I is between 1 and m, and j is between 1 and n. In other words, two matrices are equal when their corresponding entries are equal. So we're just going to take a look at this, solve for A sub 1, 1, A sub 1, 2, A sub 2, 1, and A sub 2, 2 in the matrix equation. And so just briefly, just want to show you that basically all you're looking at is this A1, 1, that is 2. So A1, 1 equals 2, A1, 2 equals negative 1, A2, 1 equals negative 3, and A2, 2 equals 0. And I'm sure you could do the same thing down here, just seeing that their corresponding entries are equal. Let's do addition of matrices. It's actually pretty quick. So let me just show you the long way of what this looks like real quick, and then you could probably do it in your head. You're just adding together the corresponding entries there. So we're going to add negative 1 plus 1. Then we have 2 plus 3. Then we have 0 plus a negative 1. And then we have our last one, 1 plus 2. Then you add those together. So negative 1 plus 1 is 0, 2 plus 3 is 5, 0 minus 1 is negative 1, and 1 plus 2 is 3. So you can do the same thing here. So we could just add it as it is. I'm sure you could do it in your head. 1 minus 1 is 0, negative 3 plus 3 is 0, and negative 2 plus 2 is 0. Letter A. Now, could we add these? We cannot. This is not possible because they're not the same, right? They're not. This is a 3 by 3. This is a 3 by 2, 3 rows by 2 columns. So therefore, this is not possible. Or we can say it's undefined. Either one is good. So try these 4 real quick. Okay, we tried this out. These are the answers you should have gotten. The only one that was not possible was this one down here because it's not the same dimensions. So a symbol negative A, for example, represents the negation of A, which is the scalar product negative 1 times A. Moreover, if A and B are of the same dimensions, and A minus B represents the sum of A and negative 1B. So, you just do the work by distributing that negative into the B, and then you add them together. So let's try, adding, subtracting, and so forth, and then multiplying by a scalar. So letter A, for example, if you have 3 times A, all you're going to do is you're going to multiply 3 to everything inside. So just to kind of show you the work real quick, if you're multiplying 3, you're multiplying it to every single thing in here. Yeah, I'll show you the long way for that first. You just take the 3 and okay, so I'm going to do it right here because I'm running out of space. So I'm multiplying 3 times every single thing inside. Oops. So this becomes the first row 6, 6, and 12, then negative 9, 0, negative 3, 6, 3, and 6. Letter B, you're just finding the negative of everything, so I think you can do that, right? Just right where it is. So negative 2, 0, 0, negative 1, 4, negative 3, positive 1, negative 3, and negative 2. And then you have 3a minus b, and in this case, this is kind of nice because it already had us do the work for 3a and the negative b here. Oh, I'm missing a number here. This is negative 2 up here. So let's do that. So we're going to just subtract these two, or since we already distributed here, notice we distributed that already, you're just going to add this matrix with this one. And so this is what we get. 6 minus 2 is 4. 6, and then 12, and then negative 10, 4, negative 6, 7, 0, and 4. So try these below. If we tried this out, you would get the following information. So first you have to a minus b, so you need to distribute a negative here. So I did that first. Negative 4, positive 1, negative 3, negative 1, and negative 7. Then we add it. So we get 4, negative 5, 0 plus 1 is 1, 4 minus 3 is 1, negative 3 minus 1 is negative 4, and 8 minus 7 is 1. Then here I just distributed the 3, multiplied the 3 through every single term inside. And then here I multiplied the 3a, or actually I took what I had here, and then I multiplied a negative 2 to b, and then I got these numbers here, and then I added it together. So just some properties of matrix addition and scalar multiplication. Let A, B, and C be m by n matrices, and let C and D be scalars. And so notice the commutative property here. So when we add, that doesn't change, right? Because we're just adding. Associative property, we could add BC together and then, and then add A at the end, or do A, B together and get C, and that's still okay. The associative property, scalar identity property, that should make sense, right? 1A still equals A, and then the distributive property still works there. Another thing just to kind of note, just for the homework, if you have A times B times C, that works the same, right? You just multiply A times B, and then when you multiply, after you multiply that together, then you multiply C together, just as a note. So let's do the addition of more than two matrices. Hopefully that should be pretty intuitive. You can kind of figure out what we're doing. You're just adding straight across, right? 1 minus 1 plus 0 plus 2, and then you get your answer. So that's all you have to do with these. So 1 minus 1 is 0, and then so the answer is 2. Here we get 2, and the negative 1s go away. 2 minus 3, that would be negative 1. And then here we get, this goes away, and so we're left with 1. And so I'm sure you could do this here real quick, so try this out. So 3 minus 2 is 1, 8, negative 8 plus 7 is negative 1, negative 1 plus 3 is 2. Then we have 0, 6, and 4, so that is 10. Then 2, negative 5, and negative 1. So that is negative 3 minus 1 is a negative 4. Now evaluating an expression. So here we have 3 and then parentheses negative 2, 0, 4, 1 plus 4, negative 2, 3, 7. Now it's up to you however you want to do it. You can add first and then distribute the 3. It's up to you. But let me do it this way. So I'm going to go ahead and distribute the 3 into each one and then add them. Either one works though. So this becomes negative 6, 0, 12, and 3. And this one is 12, negative 6, 9, and 21. And then we just add them together. So we get 6, negative 6, 21, and 24. So try this example here. Okay, we tried this out. You should have got negative 6, 6, negative 10, and 6.